which is still better than nothing. All right, so we are recording, it's good. All right, so this is the Moodle website. Let me just zoom in just a little bit so I can kind of talk about which part you have to sign in. So this is where you can type in your username. Your username is W followed by your 7-digit student ID. So it's the same way to sign in as D2L or Canvas or your apps.losrios.edu account. The password is the same password, so it's the same as your district password. So pretty much the same stuff, okay? If you're already enrolled in this class, you should find yourself in Moodle already and also linked to the class for this particular class, okay, the site for this class. The way I sign in is a little bit different because I've been, I guess, different in the way that I cannot remember my password. There we go. Okay, so this is the main site. You will find your classes over here under My Courses, and cisp440 is down here for me. If you're only taking one class from me, that will be the only entry that you will find. Okay. Once you sign in, you won't see the items that are grayed out because those are quote unquote invisible to you. So if you see something that's grayed out in class, during my presentation, you won't see it as a student. Okay. All right, so I'm just going to point out the interactive syllabus is right here. It looks like a quiz, except it is not, okay? So I will give you a quick preview of that. And 3 people have at least started in the test, so I'll give you a preview. So it basically just talked about the section, and then the next question talks about me, when my office hours are, and also, this is actually incorrect. I have to fix this too. It's using, there we go. That's the good thing about technology, because I can now change it right here. I use a new account for each semester, so this way I don't have to clean out the other one. And Moodle has, Google has not complained so far. There we go. So it's good. Office hours are actually much more friendly to you guys because it is Monday, Wednesday, Friday from 8 to 9. Tuesday and Thursdays are right before this class. So it is from 4:30 to 5:30. There we go. All right, so everything else is correct. Same changes. All right, so you just have to kind of go through all of these questions and make sure you know what you're reading before you check one of the answers. So at the end of everything, you will turn in the whole quiz. So you just click next, and it will ask you to confirm that you are ready to sign in. Yep.
So if we want to go back to the syllabus to check for something specific, like figure out your contact information and we didn't write it down, would we have to then retake the entire test?
Nope. You can go back and you can see your, all the questions, quote unquote questions.
Okay.
Yep.
Was that 8 in the morning till 9 in the morning, or was that at night?
It's a 24-hour format, so 8 to 9 is in the morning, but I also have Tuesdays, Thursdays, which is today, from 4:30 p.m. to 5:30 p.m. So for this class, it's really convenient. It's right before the class. Yep.
The schedule seems to be from 12/16 as well.
Okay, so I have not updated yet. Just add a few months to it. I don't usually follow it anyway, so I'll adjust it, just for formality purposes. But everything else should be, the correct, all the, grading standard, and stuff like that. They're all, correct. So I'll leave it up to you guys to do this. But until you are done with this test and score 100%, you cannot move on and actually do your homework. So I would suggest you guys to do this as early as possible. One more thing, you might want to write this down, because if you don't write it down, the video itself cannot help, because I'm just about to tell you where to find the video, the video of the recording of this class. So you want to go to youtube.com, and the quickest way to get to it is really just type, you can't see it, but it's, let me pull this down a little bit. it's some profs. Okay, so if I just write, maybe I'll write it in here. So you just go to youtube.com/someprofs. That's where you will find all the recording for all of my classes, and it will look like this. And you go to videos, and it will list all the classes in reverse chronological order. The last entry is the most recently recorded one, and then you can scroll all the way back, I think like 2 or 3 years, I cannot remember how long. I think there are more than 1,800 recordings at this point, and most of those are an hour and 20 minutes long. But YouTube or Google has not complained yet, so I'm not gonna delete anything. It takes too much time to delete something, so I'll just leave it there. Okay, are there any questions? Any questions about where to find the class material? Any questions about where to find the class recording? Okay, no questions? Just a little bit of a tip, okay, when you take classes from me, because most of the time, unless I forget or there's a technical difficulty, there is video recording for this class. So it might be helpful for you to note when I talk about a particular topic on your notes, okay? Because this way, if you just need to revisit, okay, I remember Tad talked about existential quantifiers, okay? But I cannot remember exactly where or when he talked about it. Just jot down the title, okay, the topic itself and the timestamp. So you can just say, oh, it's 5:45 right now, so it'll be about 15 minutes into the recording of that particular day. So that will help you find which day and what time within the video to get to a particular topic really quickly. So I think that can be useful if you make use of the resource of my recording. Okay. Any questions about all this stuff here? So I'm going to leave it up to you guys to read and complete the syllabus, and we can then just move on and talk about the main topic for this class. This is cisp440, and I have been moving my notes a little bit from the Moodle format to another format. Okay, the other format I have been using before I started to use Moodle to write my notes. But because of Moodle being so easy and convenient, I have used the Moodle way to do things for a while. And then in 2018, which is next year, Moodle will no longer be around because of Canvas. So I have to go back to the old way of doing things. Because Canvas doesn't have a really good way to enter math equations. It does have a way to enter math equations, but the length of the equations is very limited. And as a result, some of my equations cannot be entered in Canvas, so I have to find a different way to do it. All right. So what we'll do is we'll start with this particular slide here, and this is where I put all my notes at this point. The nice thing about this way of doing things is you can, for those of you who like to print stuff out and put it into a 3-ring binder and stuff like that, you can go for the PDF, okay? Print out the PDF, hole punch it, and you can put it into a binder. For those of you who like to read stuff from the web, from the browser, you can just go for the HTML version. They are identical, okay? Content-wise, they're identical. One is just for printing, and the other one is good for browsers or electronic devices. Are there any questions about this? Okay, and you are free, feel free to download these documents, just so that you have a copy on your device. So this way, you don't have to go back to Moodle all the time just to find it. I'll just go ahead and show you what the PDF looks like. So this is the PDF version, okay. The picture may not render as the same way, but the content would be exactly the same. And then the other one is HTML, which is about the same thing, except the picture renders a little bit better. Okay, we'll get to the picture, don't worry. All right, so I just wanted to kind of start this class with a very kind of superficial discussion of what is truth and what is logic, and also in the context of these two things, in the context of mathematics, physics, and just logic and computer science. Just to kind of give you guys a context of this class, because I'm pretty sure, even though you don't raise your hand or let me know, 2/3 of this class is basically saying, why am I here? Okay, because this is not a computer class, this is not a programming class, this is more of a math class than anything else. So you might have that question. So I'm hoping that this might answer the question. All right, so the way I do my lecture is kind of read my own notes here, but I don't like reading my own notes. So I'll just kind of highlight which part of the notes I'm reading from or what I'm talking about, and you guys have to kind of read it on your own. Okay? So we kind of know what physics is. Okay, physics has to do with matter and energy. Okay, but if you ask Einstein, it's the same thing, right? E approximately equals to mc squared. Okay, but that's kind of physics. When you talk about mathematics, what is math? If you ask a math professor and say, okay, what is mathematics? What do you think a math professor will? How do you think a math professor will answer?
The study of numbers and their relationships?
Yeah, numbers, relationship between numbers and the structure of numbers, values, and that sort of thing. Okay, and logic is the study of the structure of reasoning. Okay, so it's kind of a little bit different, even though we do use logic in math and we use math in physics, they are a little bit different. Okay, so we'll take a look at physics first. Okay, by no means am I implying that physics is easy. In fact, I would say that physics is a whole lot harder compared to computer science. Okay, and I'll explain why in the later part of this note here. So physics consists of a collection of theories to explain how energy and matter work. Okay, a theory uses mathematics to relate one or more physical quantities to other types of quantities. So E equals mc squared is a typical example. Okay, and this won't be in the test in this class. Maybe in your other classes, but not in this class. Okay, E is energy, M is mass, and then C is the speed of light, which is a constant. Okay, so it's a relationship. Okay, we are given a particular mass, and I would ask the question: how much energy is contained in that mass? Okay, what is the equivalence in terms of energy? And then you can use this equation to say that, well, it's approximately that much. Okay. But then the most important part of physics is a theory can only be validated by repeatable, objectively observable experiments. In other words, a theory can be invalidated by an observation in a lab. Okay, and say that, hey, the theory says this is going to happen, but what we observe is something different, so the theory is disproved. Okay. So as a result, physics, no matter how complex and abstract, is still grounded to the physical world. Okay, we have discoveries all the time. Okay, and we invalidate older theories all the time too. Newtonian physics says what? If you're on a train and you throw something out of the train, so let's say you're on a train, you're already at half the speed of light. Okay, so instead of throwing something, you shine, light ahead of you using a flashlight. So what would be the speed of that photon that's coming out of the flashlight according to Newtonian physics? It would be 1.5 of the speed of light, because you're already moving at half the speed of light, so anything that you're throwing out ahead of you is going to have at least that much speed plus the actual speed between the object that you're throwing out and the platform that you're standing on. What do you think Einstein has to say about that? So Einstein said the speed of light is constant. Nothing can be faster than the speed of light. So what do we do about it? Well, since we cannot change the speed of light, so the photon that is coming out of your flashlight when you are already going at half the speed of light, that photon is still going at the speed of light. From whose perspective? From everybody's perspective. Okay? But how can that be? I'm already at the speed of light. If I shine a beam of light, how can that also be at the speed of light? What can we tweak
Wavelength.
time and space. We tweak time and space just so that the speed of light is constant. Okay? So it is observable too. Okay? So we can actually prove that Newton was almost right about everything, except when things get close to the speed of light. Then it doesn't seem to apply anymore. Okay? All right, so we move on to math. Mathematics has a lot of branches, and let's consider something that's relatively simple, like algebra. So in algebra, I'm going to skip a whole bunch of stuff here. We'll just talk about addition in algebra. What do you think? Why do you think people studied mathematics? Or why do you think mathematics is important? Think about cavemen. Don't even think about your classes here. Don't think about calculus. That's way, 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 way too abstract. Think about cavemen. Why do you think they need math?
Because of the importance of quantities and therefore the ability to do things with those quantities.
Because if caveman A has 3 coconuts and he wants to exchange for 2 pineapples, he has to express quantities, right?
Sure.
And at some point, you don't want to always bring your pineapples and coconuts with you, right? You want to have numbers so they can show, hey, I got this much this thing, and I want that much of your thing. Is it a deal or not? Right? You always hide the club behind you. But we need representations of quantities, and that's why we have numbers. It's language, okay? It's just for expressing the quantity of stuff. But we can do things to these quantities, like addition. Okay? So we can say, hey, 2 plus 3 is 5. How do we know that? Well, the caveman can probably just look at 5 pebbles, right? 2 pebbles on one side, 3 pebbles on the other side, combine them and count 1, 2, 3, 4, 5, and 2 plus 3 is 5. Okay? So they can define the rule and just say, hey, I have just discovered a really important rule, 2 plus 3 is 5. But that is not really that helpful because what about all the other additions? So at some point in all the rules, at some point people find out that, hey, 2 plus 3 is the same as 3 plus 2 because they all come to the value of 5. And somebody probably then say, hey, maybe in general we can also say that x plus y equals to y plus x. Does that make sense? In other words, we are abstracting things. We are losing the not so important details and just trying to get to the essence of all of these observations. Now, just because the commutative law of arithmetic is kind of intuitive, is kind of obvious, doesn't mean that it cannot be proven. It can actually be proven. So for those of you who want to kind of look into how people prove the law of the commutative law, you can go to this Wikipedia page and just actually read it a little bit, just a little bit. I'm not going to quiz you on this. I just want to show you that what we thought was given is an axiom. We don't even question it. It is just given to us. Well, as it turns out, somebody in the 19th century actually proved it using some even more elemental type of math. Okay. All right, so the bottom line of math is it doesn't have to be grounded to the physical world. Okay, these are not physical laws. These are artificial laws that we are saying, hey, they seem to be really useful. Let's go ahead and make these laws. And as a result, they cannot be. You cannot prove that mathematics is wrong because it doesn't match reality. Are there any questions about the comparison between math and physics? Okay. Well, that kind of this reminds me of a particular question. How many units is calculus 1 here at AR? 5 units. How many of those units are lectures? All 5 units are lecture? Okay. Okay, so because what I was trying to get to is, is there a lab component to math classes? Because it doesn't seem to make a lot of sense to experiment to understand math. Okay. What about logic? logic actually exists long before mathematics is formalized. Okay, math is actually pretty young compared to logic. So we have a little story here. Okay, so caveman Mundo, observes that in order for animal tracks to be formed, the soil needs to be moist, and an animal has to walk on that moist soil. As caveman Mundo hunts, he came to an area where no animal track was visible. Without even taking this class or any logic class, Mundo figured out that at least one of these two conditions is missing in order for there not to have animal tracks. Okay, so think about the three scenarios where there can be no animal tracks. The soil was dry the entire time, but an animal did walk by, but didn't leave any footprints. 2, the soil was moist, okay, at least once, but no animal was around to walk on it, and therefore there were no footprints or no animal tracks. And then the third one is the soil was not moist, and there were no animal. So those are the three combinations that can end up with no animal tracks that Mundo could observe. So Mundo had time, and since he could not confirm that there were no animals, he decided to spend a little bit of time to look for animals in that area. Because if Mundo can confirm and just say for sure there won't be any animals, he can just move on. But that's not a conclusion that he could have drawn at that point. So he just said, well, maybe I have a little bit of time. I can just look for a few animals. Does that make any sense? Do you think cavemen are capable of applying logic? I asked it as an open-ended question because I do not know for sure. But I think it's intrinsic to our brain structure that we can actually do that. We do not have to be taught to do it. Okay. So logic does not deal with quantities of the explanation of physical phenomena. It deals with the structure of truthfulness. In other words, if this is true and that is true and that is not true, how do those things impact this particular statement here? In addition to being useful as a standalone tool, logic is useful as a standalone tool. It is also used in mathematics to connect axioms and theorems. Mathematics, in return, is used in physics to model physical phenomena. So you can kind of see how logic is really, really important in anything STEM. Okay, STEM. Does everybody understand what is STEM, which is an abbreviation? Science, technology, engineering, and math. Okay, very good. Logic probably did not come in its current form, which is kind of formalized and use a lot of symbols in ancient time. And the interesting part is, if you look into the history of logic, multiple civilizations came up with logic or the study of logic basically simultaneously. Okay, it's not linear. It's not like one person discovered one thing, the next person follows up, and so on and so forth. It's just simultaneously, it was simultaneously studied and recorded by different people in different civilizations. So this is just my speculation, but I think what happened is Mundo probably had numerous observations. Okay, and based on the numerous observations, he came to some generalization. And then it's those generalizations that became quote-unquote logic. Okay, in other words, it was not formalized, initially, but based on observations, people start to, understand, oh, there's a certain pattern to do things. So the third topic is about this picture, and I'm gonna zoom out to the point where you can read, you can look at the entire picture. I'm not sure whether you guys can read you can read the words. And what I really want to focus is the thought bubble. Okay, you don't have to send me an email if you agree with that guy. Okay, do not send me an email if you agree with that guy. Okay, I just want to learn how to program video games. Why am I in a class that talks about logic, that talks about math and stuff like that? Why do you think that is the case?
It's important to making games if you want to do that.
Say one more time.
Because it's important.
It's important? But why is it important?
You need to understand it to build things, basically.
Computers are fundamentally all about math, so you need to understand math in order to understand the details of how they actually work.
Not according to my idiot's guide to game programming. Or learn how to program games in 24 hours. Yep.
You can prove that what you wrote should work without testing every possible form of input.
And why would that be useful?
Well, because especially in the workplace, you'd like to sell a product that you can verify is actually going to work as you expected it to. But in computers, there's a lot of unintentional implications if random bugs pop up in runtime after you released it.
Absolutely. Okay. But can somebody become a game programmer or a web script developer without understanding a whole lot about math without taking this class? The answer is yes, but what?
Not a very good one.
But not a very good one. Very good. Yeah, go ahead.
Like the skills that you learned from that mathematics stuff, you can use those skills to like become a better programmer even though they're not necessary, but they're good skills to have.
Yep. I look at logic and math, especially the content of this class compared to computer science as martial art or other types of karate or other types of martial art for policemen. Okay, if you know karate, does it make you a super cop? No. Does it help? Okay, it helps. Okay, so it's kind of like that. It's not directly related to what you're about to do, but it does form the basis. It does give you the fundamentals of what you need to do. Okay, so when I scroll a little bit, I start to explain all those things. So I use two particular examples. In this case, why truth matters. Okay, why do we know about something, whether something is true or not? Okay, so in this case, I try to use computer security to explain, why we need to know whether something is true or not. Why do you think computer security is something that I might want to bring up occasionally in this class?
Because encryption often uses lots of complicated math to hide information.
Okay, but we are not going to get to that kind of complicated math. Computer security itself as a field, as an employment, why is that important?
Because that's where errors are most obvious. When something breaks in computer security, it becomes very big, very fast.
Okay, and why do we care more about computer security now compared to, let's say, 1980?
Oh, because we've had so many issues of like data breaches and abuses in computer security since then.
Well, we had those back in 1980 as well, but they came in the form of floppy disks. How do you spread a virus in 1980? You don't text, you don't email, you don't post, you don't browse, you don't search. What do you do? Exactly, you share a floppy disk. That's how you can spread a virus. How fast can you spread a virus when it needs a floppy disk? Not very fast. But it will probably still hit a majority of the computer because there weren't many to begin with. But once you infect the computer, how do you get all that secure all that sensitive data back to mothership?
Go back and even more fluff.
That becomes a pretty hard thing to do, right? You kind of have to have your virus to print on the screen and say, you print this return label and pay for the postage and ship this floppy disk back to this address. That would be the only way for that sensitive information to get back to quote-unquote mothership. So, as you probably know, computer security was not as much of a problem as it is today. Okay? But why would you care about, hey, computer security is a big deal now? Why would that impact you? Why is that important to you?
So even like all your personal information in the computer, your social security, everything, all your life, pretty much.
Okay, so that's at a personal level. Okay, you want to make sure that your stuff is safe. Okay, that's good. That's a good reason. What else?
Write secure code.
You have to write secure code, okay? Yep.
They can rewrite your program. They can rewrite your program.
They can rewrite your program. Who can rewrite your program?
Whoever can get onto your system.
Okay? But why is it important to you as a student? How many people are planning to be a student like forever?
Kind of, yeah.
Okay, so most of you are planning to get a job, right? So what kind of a job are you gonna get? Game programming. I want to do game programming. Well, that's good. Okay, there's nothing wrong with game programming. In fact, the gaming industry is now how many times the size of Hollywood? It exceeded Hollywood like a few years ago. So now I would imagine it's like twice the size of Hollywood at least. Okay, in terms of revenue. Okay, so there's nothing wrong with game programming. What about computer security related jobs? What about those? Those are even more important, okay? Because when you're dealing with game programming, okay, it's competitive, okay? The other company is trying to release a new game that has about the same kind of elements, so in order to stay in business, you have to be competitive. So there's competitive or competition within these companies. But when you're talking about computer security, what is the relationship between organizations? Are they competitive, or is there something else going on? They're hostile, exactly. They're hostile, they're adversaries. And how many adversaries do we have as a country? Just about everybody else, and then some in the United States.
Some on the inside, yeah. Thanks for saying.
Okay, so that means that there'll be a lot of jobs related to computer security. When the economy goes down, do people buy new games? Well, maybe I don't want to spend too much money to buy another game. So the game industry will, lose their revenue. They might, cut off, some of their employment. What about computer security?
Never die.
Exactly.
You might transform, but it won't die.
You might even have to hire more people when times are bad. Okay. All right. So now that we understand why computer security is important, let's go ahead and look at these two things. There are mainly two types of security holes. One type of security hole has to do with the principle itself or the assumption not being sound, or over time it is no longer sound. So in the past, okay, I guess back in 1980, people think that the MD5 hash function is practically non-reversible. It's a one-way hash, so if you store a password as a hash value, there's no way somebody can look at the hash value and get back to a text string that can be used to sign you in. Okay? Well, that might be true in 1980 because computers were very slow in those days, and it is really hard to come up with the right combination to come up with the same hash, value. What about these days? Today, if I store my password in MD5 hash without salting it, okay, and somebody got a hold of the MD5 hash of my password, what's going to happen? Well, they can get back to a text string that can come up to the same MD5 hash. May not be the same password as mine, but since it doesn't have to be the same, it just have to map to the same hash value, you can look up a rainbow table to get it. So these days, MD5 hash is no longer considered, useful for security purposes. It's useful for other purposes, just not for security. Other things in computer security can be because the implementation is faulty. There's nothing wrong with the theory, but the implementation is faulty. How many people still remember the SSL Heartbleed vulnerability? Okay, a few. Okay, how many people have never heard of this? Okay. So you might want to look it up. Okay, so the quickest way to look it up, this is what I do all day long. Select, right click, search Google. Yep.
Did you see the most recent one that was that level flip punch web? There was another vulnerability they discovered that's actually our
In OpenSSL?
No. In cloud computing, where they could actually do like individual bit manipulation of other people's stored data.
Oh. Okay, so if you want to read about this particular problem, which happened like a few months ago, maybe a year, there's a website dedicated to it. They kind of explain what it is, but the bottom line is the theory itself is not a problem. SSL, the encryption layer, there's no problem whatsoever with those. It has to do with the implementation. Okay, it has to do with the implementation of a very minor, little used part of SSL. Okay, it's called a heartbeat, basically saying, yes, I'm still here, okay? But they can trick the library to reply with a chunk of memory that is not what should be replied. So by doing this, they can actually get to the passwords, they can get to the memory that is allocated for something else. And as a result, they can hack a server and recover passwords and other types of really useful information from the server. But it all has to do with probably somebody used string copy instead of string and copy. Okay, now that you guys should remember, okay? Yes, no? How many people know what is string copy as opposed to string and copy? One has bound checking and the other one does not have bound checking. This is probably the problem of the lack of bound checking. Okay? So it's an error, okay? Somebody wrote the code wrong and ended up with this big security hole. But in each case, we have a truth assessment that is needed. Okay? This is a statement. MD5 is practically not reversible. The question is that true? Okay? Is it true that it is not reversible or practically not reversible? What about the other problem, the hard bleed vulnerability? The question is, does the program, in this case the SSL library, behave correctly when asked to read beyond the allocated memory? Okay, it's either true or false. Okay, but obviously somebody did not check. Okay, and therefore we have a problem. All right, so now that this part is done, let's go back to the class again and continue. These two are basically a repetition of this part here. You're more than welcome to read it, but there's not a whole lot of useful information in it. This is your first homework assignment. Your homework assignment is a math JAX exercise. And what I want you to do is to use the built-in Moodle editor to enter this thing here, okay, this long statement here. Okay? And you have to use, either use MathJax or you can use the equation editor that is built into the Moodle HTML editor. You can probably do most of it except for the funny looking Z. So the funny looking Z, what you do need to do is something that you have to do anyway. So this is not a detour or some extra work that you have to do, because you have to read my notes on set theory. And there will be some places in the set theory that will show you, this funny looking Z, and by right clicking it, you will probably figure out how to put that in. Okay? So that's something that we're going to do next. Okay? We're going to talk about set theory right now. So this is your homework. And we are now going to set theory, starting with the rationale of set theory. Now, set theory is the foundation of many branches of mathematics, probably not so much in calculus, but anything that is discrete, has a lot of set theory behind it. And this slide doesn't really talk about much, other than, this is the vocabulary of what we need to do. There are actually practical reasons why we need to understand set theory as well. There are certain types of practical programming where the concept of a set is actually used, but we're not going to spend too much time to talk about it. Before we talk about set theory, I just want to confirm and make sure that we all understand these basic Boolean operators in C and C++. I'm just going to highlight it and ask, are there any questions about this operator in C or C++? So questions? Okay, so let me ask you, what does it do? Say again? is an AND operator. Well, there are two AND operators. One is called logical AND, and the other one is called bitwise AND. This is a logical AND operator. Very good. And let me go ask you another question. I'm going to put this using a text editor so that this is all recorded in the video. I'll ask you this question. What is 5 and 7? If I were to evaluate this expression in C or C and print out the value using a cout, what do you think is the output? Any non-zero value. Okay, I like that answer. In other words, the answer can be 5, can be 7, can be 57, can be 1, can be -1, it can be anything other than 0. Okay, very good. Because in C and C++, if you want to represent true and false, a Boolean value, 0 is false, anything other than 0 is true. Okay? So that means the 5 is representing true, the 7 is representing true, true and true is true. So that means the entire expression is true, which basically means it is anything other than 0. Okay? This is bar, or two vertical bars right next to each other. It is the OR operator, or to be more precise, it's the logical OR in C and C++. So in this class, we use the math symbols. We use this little inverted V symbol to represent conjunction, which is AND. We use this little V symbol to represent disjunction, which is our OR. And this is negation, which is represented by a single exclamation point in C and C++. Are there any questions about conjunction, which is AND, disjunction, which is OR negation, which is NOT, in C and C++? How they're used, how what the behavior of these operators? Are there any questions about that? No questions? Okay, very good. So here I'm just going to be a little bit redundant to talk about the truth tables. In the truth table, we have one column. In this case, it's the column of x that is representing the independent variable. The value of this variable does not depend on anything else. And then the other column in this case is the value of the expression. What is not x? Well, when x is false, not x is true. When x is true, not x is false. That's how we read a truth table. Are there any questions about the truth table for negation? Logical negation. Okay, no questions. Here's another one. This is the truth table of conjunction, which we know as AND, right? So now we have two independent variables. Both x and y are independent variables. That means the value of x does not depend on the value of y. The value of y does not depend on the value of x. So that's why we have 4 possible combinations. Because when x is false, y can be false too. But the result of y, x and y is also going to be false. X can be false when y is true, and the result of false and true is false. The result of true and false is false. The only time you have the conjunction returning a true value is when you have true and true. So in this case, I'm using 0 to represent false, using 1 to represent true, which is something that is going to carry out through the entire semester. So instead of using TF, like in some of the other classes, I just use 0s and 1s. Okay. Moving on to disjunction or, okay, nothing mysterious here. The only time you can get a value of 0 or false out of a disjunction is when you have false or false. Okay, if at least one side of a disjunction is true, then you have true as the value of the expression. Any questions about all of this stuff here, the truth tables? Okay, these are the things that we should be familiar with. Here comes something that may not be as familiar. Okay, this is implication. Implication can be written in 2 different ways. It can be written as if x implies y, then we can either express it as not x or y, which is using the operators that we have already defined, or we can use a right arrow in this case using 2 bars. Okay? So when you see x and a 2-bar arrow pointing to the right-hand side y, it also means x implies y. Okay? The definition of x implies y is defined in this table. False implies false is true. False implies true is true. True implies false is the only time that the implication itself is false. True implies true is also true. Are there any questions about implication? Not the truth table, but the meaning of implication. No questions? Okay. Go ahead.
I didn't get it. Can you give us more information about the implication?
Okay. So this is the definition. In other words, this is how we define implication. But the question is, why is implication useful in logic? And what is the actual meaning of implication? Okay, that's a very good question. So I'm going to give you an example. Okay, let's get rid of this. So let's just say that, as a class, okay, you guys, each person contributes $1. Okay, so as a class, you guys gave me like close to $50 to ask me for a word of wisdom. Okay, so I'm going to give you something. Okay, so I'm going to say, thinking about something that relates to this class. Okay, so I'm going to say implies everyone fails cisp440. Okay, so now I have to attach something to it. Okay, I have it. Deadpool 2 is not popular. There we go. Okay. This is my word of wisdom. Okay, you guys just paid me to give you something that is supposed to be the words of wisdom. If Deadpool 2 is not popular, okay, which is not released yet, right? I think they're still having problem finding the producer. Yes? No? Does anyone know? Okay. Anyway, so that means it's up in the air. Implies everybody fails cisp440. And somebody can say, it makes no sense. Okay, there's no causal relationship between these two things. Doesn't have to be. Okay? An implication doesn't need causal relationship, doesn't need correlation. It really is just a statement. Okay? You pay me, I give you my words, I give you a statement that may or may not be true. Is that okay? So you guys were not happy with what I just said here, okay? Because that $1 doesn't seem to be well spent. So you want it back, right? With interest. So at the end of this semester, how can you get that $1 back? Okay, so let's figure out, okay? Okay, so this is my statement. So I'm going to give you 3 columns here, okay? So I will go back to this part, okay? So this is my statement 1, okay? So this is 1 column, which can be true or false. So I'm going to call this, statement 1. This is statement 2, which can also be true or false. And this is the last part here is important because it is the truthfulness of the implication itself, okay? So I'm going to call this statement 3. Statement 3 is the entire thing. This is a statement. It can be either true or false, okay? Once Deadpool 2 is released, we can figure out whether it's popular or not. This statement is also a statement. It can be true or false. To be more exact, we can say, everyone in this particular section, okay? So that way it becomes a lot more specific. But it's also a statement that can either be true or false, right? So it's just a statement. But this entire thing is also a statement. It can be true or false. If it is true, you cannot get your money back. If it is false, I will return your $1 with interest. Okay? So I think you guys are slightly more interested now in implication than a few minutes earlier. Yes? No? Do you want my PayPal account? just so that there's more stake in it. Okay, so let's go ahead and figure out, the 4 ways that these things can turn out. Okay, Deadpool 2 was released. Okay, and it turned out to be a flop. Okay, everybody hated it, and for some reason, everybody failed this class. Can you get your money back?
Yes.
No, because what I said was right. Okay, you cannot get your money back when you cannot prove me wrong. Okay. Deadpool 2 was released. It was a flop. But, as far as this class is concerned, okay, everybody passed and many people got A's. Can you get your money back? Yes. Because what I said was wrong. Okay, so you get your money back. There you go. What about Deadpool 2 was released and it was a hit? Everybody liked it, just like the first one. Okay? Well, as it turns out in that case, it doesn't matter what happens to this class, nobody gets your money back. Because my statement is saying Deadpool 2 being not popular implies blah blah blah. Well, if the first statement is false to begin with, I'm keeping your dollar. Because I never said anything about what if that is not true. That's the idea of implication. Okay? The only time an implication is false is when the premise is true, but the consequent is false. That is the only time the statement itself, the implication statement itself, is false. And that's the only time you can get your money back. Are we doing okay so far with implication? Okay. All right. So with implication defined, we can now define equivalency. Equivalency is really, it looks just like implication, except the arrow goes both ways. Well, that's because the definition of equivalency is x implies y and y implies x. They are equivalent. When x is true, y has to be true. When x is false, y has to be false. When y is true, x has to be, what did I say? False. And then when y is true, x has to be true as well. So they are linked now. Okay. So we can look at this truth table, for equivalence. Once again, we have x and y being independent variables. X implies y has this column, y implies x has this column. But because x is equivalent to y is defined as the conjunction of these two columns, then we have false is equivalent to false being true. True is equivalent to true being true. But in between, they are all false. Are there any questions about equivalency? They're just definitions of operators. Okay? In other words, if you don't want to deal with the semantics or the actual meaning of implication, just remember this table. That's all you need to remember. Are there any questions about these operators? Because with the definition of the operators, we can now move on to talk about actual topics in set theory. All right, so this is really just a whole bunch of definitions of terms, okay? So the first thing is we want to define what are elements in a set, okay? Elements in a set are basically just, things inside a set. A set is basically a container. It can contain items, okay, but we don't call those things items, we call those elements. So if a set is a container, elements are basically things that are contained inside a set. So in this case, let's just talk about, set T. Okay, uppercase T is a set of cars that I like. Okay, and I'm not going to be specific about, model year and variants and stuff like that. Just so that it stays, simple. So let's just say that I like these 3 kinds of cars. Okay, I like the Mazda Miata, I like Honda Civics, and I like Toyota MR2s. Okay, just, so it is a set of cars that I like. Okay. Okay. So you can see that we use curly braces. Okay, so this is the syntax of how to contain elements in a set. The elements are listed using, or they're comma separated, but you also have to use curly braces as to basically to contain the elements so that it becomes a set. So this entire thing is a set. Are there any questions about the syntax of defining a set of known elements? Okay, is that okay? All right. Okay, so now that we know this particular set has exactly 3 elements, and those are the 3 elements, now we can start to answer some questions, okay, or we can ask some questions. This operator here is known as quote-unquote element of. So it's asking whether the thing to its left-hand side is an element of whatever set is to its right-hand side. In other words, this is not a statement. This is not an assertion. It is not an assignment statement. It is a question. It is asking, is IATA an element of the set T? It is true. Okay, so yes, it's good, but we like true to be the answer of a question like that. Okay, so it is true. The next question is Skylark, this symbol represents not an element of? So it's asking, is Skylark not an element of T? Once again, we want the answer to be true or false. Is it true or is it false?
True.
It is true. In fact, I hate Skylarks, especially 1981 Skylarks. For those of you who do not know why Skylarks are awful cars, just look up how people tweak the timing of those cars. Okay, I can see that you guys are way too young to even have exposure to these cars. Okay, ask your parents. Okay, I'll give you a picture. This way, this way there's a reason behind everything. So let's say this is a car, this is the hood, or this is the top of the car, this is the hood, okay? So let's magnify the hood of this car. Okay, this is the front. Okay. This is the first time GM transposed the arrangement of an engine. So instead of having the engine placed this way, where the rotation is like this, they transverse, okay, to save some space. So the engine goes this way, where the rotation goes this way, okay? So as an engine originally designed to be longitudinal, mounted in a longitudinal way, it has exhaust going in one way, and then it has the timing belt and whatever adjustment on the other side. So it was designed so that people can access from both sides for maintenance purposes. When you mount this engine transposed, then you have the exhaust going this way, and then you have a whole bunch of stuff to the back side of the engine where you cannot see. Okay? So as it turns out, the timing belt adjustment thing is on the back side. So the nut that you need to loosen in order to turn the distributor to change the timing is not visible. You can feel it, but you cannot see it. Okay? But that's not why I hate it. The reason why I hate it is because the thermostat housing is right about here. So when you reach over to try to get to the nut that you have to loosen so they can turn the distributor, this part of your hand is very likely to touch the thermostat. And what is one thing about the thermostat that most of you probably would know about, especially when you're tuning up a car? You cannot tune up a car when it's cold, right? So you warm up the engine. And what do you think is the temperature of the coolant once you have properly warmed up the car? 180 degrees Fahrenheit. So there's a very high likelihood that you will touch that part, with this part of your hand, okay, which is sensitive. So that is why I hate this car. It died an awful death too. All right. Okay, so we have two statements that are true because Miata is in the set of cars that I like, and Skylark is not in the set of the cars that I like. And these expressions are false, okay? Because this is asking the question, is MR2 not an element of T? Well, that is false because it clearly is in that set. Pathfinder is in the set of T. That statement is false as well because I do not have Pathfinder as one of my favorite cars. Okay. Are there any questions about the use of this symbol or this operator, which is known as element of, and this one is not an element of? Any questions about that? Questions? All right, let's move on. So what about, there are certain sets where the number of elements are infinite. Now this is actually a clue to answer your question about the homework assignment. See the funny Z thing? That's what you need. Do you remember the instructions to do it? Right click it. Okay, so let's see what happens when we right click. Ooh. So where do we go next? So show math as. Okay, you got basically two options: math ML code or tech command. Okay, I'll throw you a bone. It's the second one. There we go. So you have a little expression here. Okay, all you have to do now is to figure out which part is responsible for the funny looking Z. I'm not going to tell you that part. I think most of you can figure that part at this point. Okay. So there you go. So that should make your homework assignment pretty easy. All right. So in this case, I want a set of even numbers. How do I describe a set of even numbers? This is how we do it. Okay, so we still use curly braces because we are basically saying whatever is between the curly braces are the elements of this particular set. Okay. What is new to us is this vertical bar, which does not mean bitwise OR. Okay, this vertical bar is basically saying such that. Okay, so we have elements X such that X is an element of Z, which is the set of all integers, and X mod 2 is 0. What does it mean when X mod 2 is 0? It's divisible by 2, or even. Yep. So we have even numbers, we have X has to be an integer, and it has to be divisible by 2. Yep.
Can you give a definition for such that?
Such that?
Yeah, like I just enjoy like truth tables and like more kind of like I get the idea kind of, but is there like an actual like mathematical definition of the operator?
Okay, I think I can approach that question. It's basically this is whatever is to the left hand side of such that is just saying, okay, here is an element of this set. Pick whatever element you want. This is what it looks like. Now there are times when there is a certain structure to the elements. In this case, it doesn't have any particular structure. So it's binding an element to a particular symbol, in this case lowercase x. And the such that, which is the vertical bar, is basically saying the right hand side is telling you about all the properties of this element of this set.
Okay, so there's two sets in the expression.
No, this is only defining one single set. This is basically saying this is a set because of the curly braces, and it says such that each element x has to make this condition true.
Okay.
In other words, the x is really just binding to a particular element in the set, so that I can use x to express the requirements for an element of this particular set. Would that help?
Yeah, I guess.
Well, should we move on to the next one? Because it might be helpful to look at another example. So now we are defining intersection and union as operators on sets. Okay. So in this case, we have x union y. We want this is intersection. So W is the intersection of these two different sets, and this is the intersection operator. In order for x to be an element of W, x has to be an element of x, and X has to be an element of Y, uppercase X and uppercase Y. Is that okay or not? Because we are pretty much using the symbols that we have just defined in order to understand what is the intersection of two sets, and then the union of the two sets are about the same, except we use an or instead of an and. Are there any questions? Okay, here's an example. Okay, so the example down here is we define a new set, okay, G, that represents the cars that George likes. George likes the Acura MDX, Mazda M Miata, and BMW 745. Okay, so the union is basically the set of all the cars that at least one of Tech or George likes. Okay, so in that case, it will be the Miata, 745, Civic, MDX, and MR2. The important part here is Miata only appears once, because in a set you cannot have duplicate elements. What about the intersection? The intersection is only has one element, because the Miata is the only car that both George and I like, and that's why the intersection T intersecting with G only has that as the single element. Are there any questions about this part? Is that okay? All right. This is called Venn diagram. Venn diagram can be used to visualize, the union and the intersection. In this case, we are drawing two ellipses, two circles, whatever shape you want to use. The intersection, which is the black portion, is the intersection. Okay, it is common to both sets. In this case, the entire thing is the union, because it covers both sets. You can also quote unquote subtract. Okay, the technical term is not subtraction. The technical term is difference, or what is in one but not in the other one. So the definition of quote unquote subtraction, X subtract Y, is an element that is in X but not in Y. So the technical definition of X minus Y is an element, every element that is in X but not in Y. Is that okay? So in this case, if I want to find out what cars that I like that George does not like, that will be T minus G, because we are subtracting, we're taking out all the elements that all the cars that George also likes. So the Civic and MR2 are cars that only I like. George does not like. George also likes the Miatas, and that's why Miata is no longer in this set. Yep.
Can you write that on the board, the two set T and G, because I'm kind of lost.
Oh, okay, because you're not a car person. That's okay. Okay, that's okay. We'll go ahead and put it here. Okay, so T is Miata, Civic, R2, and G has Miata, 745, and MDX. So, and in this case, of T minus G, we'll have to take away things that is also in G. So anything that is shared between T and G, we have to remove it from T minus G.
So if you were to flip G and T, it'd be 745 and MDX, right?
That is correct. But if you look at the Venn diagram, it is also kind of clear, because this part here, the black part, is representing what is this particular set minus this particular set. It's basically things that can only be found in one of them, but not both. Is that okay? All right. And then we have the concept of subset of, but since we have defined the subtraction already, the subset of can be easily defined. If B is a subset of A, then the following has to be true. B minus A has to be an empty set. Because B minus A are all the elements that can be found in B but not in A. But when we say that B is a subset of A, it means all the elements of B can also be found in A. Is that okay? All right. The representation of subset is this symbol here, okay? And note how there's a bar underneath to mean that it is subset or equal to, which means in this case B and A can be exactly the same set. Okay? If they're exactly the same set, they are still a subset of each other. What if you want to say it is a proper subset of? Then you say it is just a subset of where there's at least one element that is in A that is not in B. Is that okay so far? Okay. All right, so we are almost running out of time. We got 2 minutes left, so I got one little thing for you guys to look into. You don't have to do it. For those of you who do not feel comfortable doing this, you don't have to do it. But I want to point you to 16personalities.com. It's easy to remember because it's just 16personalities.com. This is the name of the website. I think this should have been done when you were taking CISP 300, okay, or when you first get into this college, okay. What it does is to kind of give you a test, okay. You don't have to sign up for anything. You just have to give it an email address. So if I were you and you are afraid that you might get junk mail and stuff like that, sign up for a new Google account and only use it for this purpose. Okay, so this way you're not giving away any personal information, nothing like that. So when you take the test, it will take about 15 minutes or so. Okay, so on your way home, if you're taking a ride, don't do this when you're driving. Take the test, and it will basically throw you into one of the 16 bins. Okay, there are 16 personalities, and hence the name of the website. And they will give you some idea of your strength and something, room for improvement. It will also give you an idea of what type of career is suitable for that kind of personality. It will give you an idea of famous people of that particular personality and so on. Yep.
You're taking roll today?
I forgot to take roll today. So I'm not gonna take roll, I will do it on Thursday. Yep.
Are there tutors for this class?
Tutors for this class? I do not know. Okay. Yep. If you need permission numbers, I think, well, since the classroom has enough space for everyone, I'm just going to add everyone. So sign into Moodle first, okay? No, okay. I'll deal with it on Thursday.
Permission numbers?
I'll deal with it on Thursday. Oh. What? The homework is due in a week. Yep, in a week. That's fine. As long as the Z is working, it's okay.
There should be 4.
Okay. So I'm just having
So you said that there's enough room for everyone to
yeah, I'm just gonna add it.
Oh, awesome. Okay, so do I need to wait for a number?
Yeah, I'm gonna do it on Thursday. So what I'll do on Thursday is I will tell you guys how to sign into Moodle and actually add yourself to the class in Moodle. So once you add yourself in Moodle, I can find out who is added to the class, and I can then send emails to those people.
Okay, cool. So I just wait until Thursday to start. Okay, awesome. Thank you.
The homework shouldn't take you too long, so I
Okay.
wouldn't worry too much about it.
Okay, thank you.
Yeah, the 430 is okay if you're not working there. 360, you should have taken 360. And also the math prerequisite, you should read that too.
I'm here till check this.
Yes, I'm INTP.
Oh, I'm an INTP.
That's right. You did
INTJ.
right.
When I was in high school, I got ENTP.
Yeah, I thought
That's weird.
INTJ and INTJ are very different.
Recording, I like it.
Talking to INTJ and INTP, they are actually very
I started
different.
last night.
That's correct.
It was like, it would have been a senior.
Yeah, we got 10 minutes. We got very people
Oh, okay.
I was kind of curious about something you showed us up there. You know the hack this program thing? I was curious to see how you hacked it.
Oh, I thought I did last semester.
Yeah, you did, but I tried hacking it on my own and I did it. I just wanted to see why you were like you were so involved in crashing it. And the way I did it was I just went into the disassembled portion and I just changed the conditional branch.
I see. I got you.
Yeah.
So you did it and the music play,
I did it like I just like looked at the disassembled version and then I changed the conditional branch to say go to the success case when it's wrong.
Right. I want to too. I guess it depends on which way it's easy. It depends on the complexity of the program.
Yeah, you did it a really weird way. I was just curious to see.
I was testing it for buffer overflow.
Okay, yeah.
Because the buffer overflow will make it crash. And when it does crash, then I can find out, okay, is there a way for me to crash it in a certain way? Because if you're looking for the conditional statement, for simple programs, it's easy to locate. It's easy to locate that one portion that you need to modify. But for complex programs,
Yeah, like your way would be better than that.
my way would find a way to gain control, and then once I gain control, I can take it to things that I need to do.
Oh, so you would have to have like the executable yourself.
Or just start a shell. Yeah.
Okay.
Yeah, but both ways work. I mean, it all depends on the complexity of the program and which way seems easier at the time.
Okay. You're teaching pretend now?
I'm in 310 right now, about 5 more minutes.
Okay.
It's too bad cyanogen mod is no more.
Yeah, it died.
But I found the guy who maintains the CAF branch of Hammerhead.
Yeah.
So now it's on his personal Google Drive.
Really?
Yeah.
I heard that he told me that he was
Maybe it's somebody else, but
Yeah, it's probably somebody else.
But the CAF branch is alive.
Yeah, the guy who originally started says, I'm tired of playing with Android.
Yeah.
I'm tired of this. It's
Yep.
madness.
Yep. It is madness because you have to deal with all the manufacturers or chip makers and stuff like that.
Yeah. I'll see you on Thursday.
All right, see you on Thursday. I probably should not show this right away. That might scare some people. Well, some people might think this is a spreadsheet class, which it is not. We'll get to it, don't worry, we'll get to that. How many people are taking 440 and 310? Okay. Did you guys check, the final exam date of both classes? Because I think they schedule both classes to have the same date. Yeah, same day, and they'll be spaced out by 15 minutes. I am not kidding. That's what happened last year. Okay, so let's check it. Where's the final exam? Your schedule has it too. Finals. Okay. Okay, so 440 is Tuesday, Thursday. So it's May 16th. 5:45 to 7:45 for 440. This class is this one. Yep, they're back to back again. It will be a fun day, yes. Because each final exam is 2 hours. I would try to space out the midterms so that you won't have that problem, at least with the midterms, but the final exam I cannot change the date nor the time. So that will be a little bit grueling for those of you who are taking both classes in the same semester. All right, well, I guess it's close. Oh, didn't